Okay, so here's where we're at. Proportional relationship. We just came off talking about what a proportion is, right? A proportion is when you have two equal ratios, correct? So, for example, 3/4 and let's say 18 24. Okay? That's an equal relationship. So I just multiplied each times 6. That's how I got that. An easier one, let's say 2/3 and what are we going to say? 4/6. How can you tell that they're a proportion again? Remember what we said? Cross products. What's 3 times 4?
12.
What's 2 times 6? 12. And so when the cross products equal each other, it's a proportion, right? So now we're going to say, now that we know what a proportion is, let's talk about what proportional relationships look like. So we're going to kind of turn this sideways, and I want you to open up your first tab right here, okay? We're going to skip to example 1. So a proportional relationship, a relationship means there's a relationship between some numbers, right? So as I'm looking at this, I see time and seconds. So we know the relationship between minutes. We know that 1 minute is equal to 60 seconds. So would that make sense then that 2 minutes would equal what? 120? And so 3 minutes should equal 180 and 4 should equal 240. So the question is, remember, I promised you some pretty easy problems today. Your homework is only going to be yes it is or no it isn't. It's all I'm asking you to do today. So our goal is, when I look at a table, do you know whether to say yes it is or no it isn't? So what would you say to this? Would you say this is or is not?
Yes.
Yes, thumbs up it is. Okay, that's awesome, but we got to talk about why, okay? So the first thing I want you to do is I want you to write, whenever you have a horizontal table like that, I want you to fill in your X and your Y. Yes.
I know how it is.
Okay, go ahead. Tell me.
Oh, when it says 1, that means what it is, and it's 60, and 60 times 2 is 120, and 6 times 3 is 1800, and then 60 times 4 is 240.
Okay, so you're just multiplying all of these numbers times 60, right? So what Xander said is, I just multiplied each of these times 60 and got that answer, and that's absolutely right. So I want to keep going back to what he said about 60. So do you remember when I asked you to find the unit rate in a table? Yeah. I said, be careful, you got to flip this upside down, and you divide so I want everybody to look up here and write, I don't know, I should have glued it a little differently. I want you to put the y on top divided by the x. So you agree we said y divided by x, not x divided by y. It's never, ever, ever going to be that. So let's do that for all of these, y divided by x. Let's take this y, which is 60, and divide it by the x, which is 1. Well, that's easy. That's 60. Let's do this y divided by this x. That's also 60. The 180 divided by 3. This is nothing new, guys, is it? We've done this. We found the unit rate, and they all equal 60. So here's the deal. You guys said, yeah, it's a proportional relationship. I'm going to tell you why it is. Because in your answers today, I'm going to say, explain your reasoning. And you have to say, it's a proportional relationship because, and here's why. Because when I divide all the y's by their x's, I get the same number. So let's kind of look up here and read this big old fancy statement. Okay? A proportional relationship between two quantities, meaning minutes and seconds, is a relationship in which the ratio, these things, of one quantity is equal to the other quantity. So we're going to put the word when that ratio is constant. All right? I know you probably want to say when it's the same. But in 7th grade, remember, it's the year of fancy words, right? So when that relationship is constant, that's when you say, yup, it's a proportional relationship. So underneath constant, let's just put the same. Let's just put maybe when they're all equal. Okay? When all my y's divided by all my x's are the same, when they're all equal, when they are constant, that's how you know it's a proportional relationship. Yeah.
So if you were to do two different ones and you got to say it
Okay, awesome. It's like you were reading my mind, because what I wanted to say next is, because I divided this by this and got 60, and this by this and this by this, what if I divided 60, I got 60, I got 60. What if this was 5 instead of 4? You know what? 240 divided by 5 isn't 60. 240 divided by 5 is 48. So would it be a proportional relationship then? No. If that 4 was a 5, I don't care if it's true for 3 of them and they're the same. Every single one of them has to be the same. So thank you for asking that. So, is this a proportional relationship? Yes. Why? Because you have a constant, you have a constant number when you do your division. Does everybody understand? Okay? Pretty easy for a table. All right? So, let's look down at number 4. Let's flip it up, but just to look at example 4. We'll come back to that one in a minute. So if I were to say to you, hey, Dakota earns $8 an hour at his part-time job. He delivers newspapers. Every hour he works, he gets another $8. Is this a proportional relationship? Yeah. Let's make a table to show that. So first thing I want you to realize is that it's missing its X and it's missing its Y, so I always want you to write that in. You do understand that that's a horizontal table, but not every table is going to be given to you that way. This is a vertical table. Do you see the difference? Know that if it's given to you up and down instead of sideways, it goes X, Y, like alphabetical order. Keep that in mind, okay? So, the next thing we talked about is cost per hour. So, we're going to put the cost because the Y goes on top. And then this is hour. All right. Something really important I want you to think about. If Dakota doesn't go to work, meaning he works 0 hours, how much money does he make? $0. Yeah, that's how it works in the real world. You don't go to work, you don't earn any money. Okay? Yeah, some people are salaried. That's different. Dakota is not salaried. He earns it per hour. So if he doesn't show up to deliver his papers, he doesn't earn any money, right? That's going to be important later. I want you to put a little star there because I want to come back and talk about that point in a minute. So let's say Dakota works for 1 hour. How much money does he make? Reese, paying attention up here. He earns $8. So which would mean then if he works 2 hours, he earns 16. Okay, now stop. I'm not going to do what you expect me to do. I'm going to say, let's say Dakota earned a total of $56. That must mean that he worked for how many hours? 7. Because you use this number to help you figure that out. Okay? Have you noticed yet that all of these X values, I just multiply by 8 and get that? 1 times 8. 2 times 8. 7 times 8. So let's say he works 10 whole hours. Then he earns what? 80. Yeah, it's really kind of easy, right? Okay, so here's my table. I know it's a proportional relationship because I made it purposely to do that. Because look, 8 divided by 1, 8. 16 divided by 2, 8. 56 divided by 7, 8. And 80 divided by 10, 8. Awesome, they all check. My constant is 8. Okay, so you don't have to write those 4. You don't have to write those in. Okay, I just wanted to show you. So you don't have to copy those. So this is kind of where I'm going to introduce the second tab to you. So before we move on to the second tab, we are 1 of 3 done. If I give you a table, will you be able to say, yep, it's a proportion, or no, it's not? Okay, here's what we're going to do. Because here's your assignment today. It is literally a maze. I'm going to give you tables. I'm going to give you equations. I'm going to give you graphs. And all you have to do is say, yeah, it's a proportion, or no, it's not. Yeah, it's a proportion, or no, it's not. So this will take you probably a total of 8 minutes, both sides. Like, it's super, super quick and easy. So let's take a look at this. Are you ready? Let's say this is the number of pirate bucks you earn per hour. Okay, say you're having a good day. So if X is the number of hours, if you don't go to first hour, you don't earn any pirate bucks. So let's say Friday, right? Friday. Nobody's going to come to school because it's a half a day. People are going on vacation. They want to tempt you to come to school. For every hour you're at in school on Friday, you get 3 Pirate Bucks, guys. Ooh, so if you don't come to school, how many Pirate Bucks you get? Nada. If you're here for 1 hour, you'll get 3. If you're here for 2 hours, you'll get 6. If you stay for all 7 hours, you will have earned 21, right? Okay, so every one of these divides by 3. Okay, are you ready? Because now we're going to transition to flap number 2, the equation. I want you to look at the front of that. I want you to put y equals, leave a little blank space and put x. Because the number that I want you to put in place of k, here's somebody who's was not an English person when they made this. K stands for the constant. Like the word we wrote right here, except you don't spell it with a K. It's kind of annoying. I wish they would have used a C. Why did they choose K? I don't know. But it means the constant, okay? So, are you listening? Shh. So, you mean to tell me as soon as I figure out that number, like 60 or 8 or 3, all I have to do is put it right here and I have an equation, y equals 3x? Yeah. It's so easy. I need to explain this a little more, though, for a minute. So is everybody listening for my explanation? Y equals 3x. This means that every single one of these y numbers is just the x number times 3. I'm going to say that again. That's how important it is. Would you agree that every single one of these y numbers is just the x number times 3? 7 times 3, 2 times 3, 1 times 3. Hey, 0 times 3, 0. Would you agree that every single one of these y numbers is this x number times 60? 1 times 60. It's what Xander said. 2 times 60. So what do you think the equation for this would be? If this equation is y equals 3x, then this equation will be... Yeah, that's it. Y equals 60x. So, what would this equation be?
Y equals 8x.
Yes. Seriously, guys, it does not get much easier than that. So, y equals 8x. If you earn $8 an hour, then y equals 8x. If there's 60 seconds in 1 minute, it's y equals 60x. So, do you see where this k comes in? It's replaced with your constant. Okay? So, here's the deal. What if I took this equation, like y equals 60x, and let's say we add 1 to it. So the number of seconds is 60 times 1 plus 1. That would be 61. Is the number of seconds in a minute 61? No. So one thing I want you to write right here on a table, whether you are going from x to y and multiplying by 3, or y to x and dividing by 3, I need you to look at one really important thing. The only operation that you can use when you're talking about constant or proportional relationships is multiplication or division. I can't have a plus or a minus sign anywhere. All right? So, do you see a plus or minus sign anywhere? No. So when I lift this next flap, I am going to give you some equations, and I want your yes it is or no it isn't answer. Yes, it is a proportional, or no, it's not. So, are you ready? Let's look at example 2. Yes, it is, or no, it's not. Y equals 12x. This person is earning $12 an hour. They're earning 12 Pirate Bucks per hour. This person earns 75 cents per something. Is this proportional? Yes. Do you see any plus or minus signs? No. That's proportional. That is. Is that proportional? It looks like it's a fraction. It's a quarter. It's a fourth. That's okay. The important thing is I don't see anything after. How about this one? No. Because I can't multiply something by 6 and then add 1 to it and expect all those numbers to work when I divide them. So this is not proportional. Give reasoning why. That's what your homework's going to say. Because I can't add or subtract anything to it or from it. That's why it's a no. Got it? But all the other ones are yeses. if you are listening and paying attention, the sheet that you're about to get in 5 minutes is going to be quite possibly the easiest thing you're going to do. It's that easy. So let's talk a little bit more about this and do a quick review. The answer to, is this a proportional relationship from a table? Divide the y by the x. If you get the same number, yeah, it is. If you don't, no, it's not. When you look at an equation, is it just y equals something x without a plus or minus after it? If it is, yeah, it's proportional. If it's not, it's got a plus or a minus. Nope, not proportional. So let's go up here. I have to fold mine so that I can write on, not on the spirals. A proportional relationship can be written as an equation in the form y equals kx. Are you ready for another fancy 7th grade word? K represents the constant, that's not even fancy enough, of proportionality. That's what that is, the constant of proportionality. Can't even fit it all on the line. All right, yeah, it's a term. It's a real fancy term. It takes a long time to write it. That's all that it means. Constant of proportionality is a fancy way of saying, oh, when I divided them all, I got 60. Yep. When I divided all these, I got 8. Mm-hmm. That's what your constant of proportionality is. Guess what? Constant of proportionality we've done before. It's a fancy way of saying unit rate. Raise your hand if you understood unit rate. All you did to divide was find out how much for 1. So how much for 1 minute? Oh, 60 seconds. How much does this get earned for 1 hour? $8. How many Pyre bucks do you get for 1 hour? Oh, 3. That's all it is? It's unit rate? Yes. So I want you to go ahead and write the word. It's unit rate. That's all a constant of proportionality is. It's just now that we're getting into graphs, we got to call it something different. That's all. Okay. So, right now, here we go. If I give you this in 5 minutes and I say, hey guys, I'm going to ask you to start here. Is this table represent a proportional relationship? You know what you're going to do? You're going to get your calculator out and you're going to start dividing. 3 divided by 1. Didn't really need to do that. 4 divided by 1.5. Oh, do I even need to go and check the other two? No. Because if those aren't the same, it doesn't matter if those are or not. So you know what I do? I shade this, and then is it not proportional or proportional? So shade this, and now I'm going to do this, which we'll do in a minute. Is this proportional or not? No, because of?
The minus sign.
Yes, so it's not. Then I do the same thing here. Is that proportional or not? No. Is this proportional? Yes. It's so easy. So are you ready to do the third way? The third way is quite possibly the easiest of the 3, if it really even gets any easier than that. And the third thing I want you to be able to tell is with a graph. All right? So let's open up these flaps and let's kind of look at this $8 an hour here. Dakota, he earns $8 an hour. So I have to label my axis. My X is going to be hours, so I'm going to put hours here. And then my Y is usually cost. Okay. I'm just going to label this as 1 and 2 and 3. You don't even really have to label those because I'm going to go by ones. But I got to go up kind of high. So you know what I'm going to do? I'm going to make like a little tick mark after every one, and I'm going to go by tens. When you have a blank graph like that, you can choose whatever you want. So each one's really going by 5. 5, 10, 15, but I don't need to label them all. 20, I'll skip that one. That's 25. This one's 30. This one would be 40, and so on, right? So you got your graph and your axis is labeled. Okay, so then I go back to like 4th grade when we used to have to plot those points, right? And you used to have to, they made all these kind of pictures, and your teacher gave you like 50,000 points on one page. I know because I just did that last week with my daughter. So I'm going to plot point 0, 0. Guess what, Dakota? You don't come to work, you don't get paid. So I'm going to put a big old dot right there. And that is called, what is that called? Where the two axes intersect? It's called the origin. Because you know usually graphs are 4s, right? 4 quadrants. That is the origin. And the origin is 0, 0. And the origin is really important in a minute. Okay, so then he works for 1 hour and he's going to earn $8. Yeah, I know, it's really little. So you have to do some estimating. 8 is just a little bit below 10, right? So if he works for 2 hours, then he'll earn 16. Well, if that's 15, I'm just going to go a little bit above it. 3 would be 24, a little bit below the 25. Let's do one more. 4 hours would be 4 times 8, which would be 32. Okay, this is awesome. So now I'm going to ask you a question. If I am about to get my ruler and lay it down on that paper, will every one of those points be on my ruler, do you think? Do they look like they're in a straight line too? They are. And they had better be, because that is the definition of a proportional relationship. It's got to be a straight line. That's it. There's actually one more thing. Yeah.
So if it's not a straight line.
Exactly. As if it's not a straight line, right away, not proportional. So you were thinking about that probably, right? Okay. So hold on. Watch. So there's 2 parts about this. Not only does it have to be a straight line, it also has to go through the point 0, 0. Because I can't have any of those pluses or minus after it. So look what I want you to write for this. The graph of a proportional relationship always is a straight line that goes through the origin. If those 2 things are true, according to your eyeballs when you look at the graph on the paper, then you're going to say, yep, it is. Okay? So, let's flip this up. It's a straight line through the origin. Yes, it's proportional. Is this a proportional relationship? No. Yep. Straight line through the origin. Yes. Yeah, Reese. If it's a straight line that goes through the origin, it's a 0, 0. It does look, yeah. It's 0, 0. That's the coordinates of the origin. All right. So let's do number 5 example together. Ready? All right. So the only thing I'm given in example 5 is a graph. And it's the relationship between feet and inches. We know that relationship. Every foot, every ruler that I get out is equivalent to 12 inches, right? So this ruler is 1 foot and 12 inches. So could you fill a table out to match that and then write an equation to match it? Let's do it. First of all, let's put our X and our Y right here. What is our X? Go to your, if you don't know what words to put, look at the X-axis. No, what's on the X-axis? Feet. So I want to write the word feet here. What's on the Y-axis? Inches. Okay. Guess what? If I don't have any rulers, then I don't have any inches. If I have 1 ruler, I have 12 inches. If I have, now be careful, let's see, if I have 2, I'm going to have 24 inches. Don't keep filling it in because I maybe write something different. If I have 48 inches, then I must have 4 feet. So here's the deal. You know your constant of proportionality, meaning K, is 12, right? Because look, what's 12 divided by 1? 12. What's 24 divided by 2? 12. 48 divided... It's all about finding that number. So if I put 5 here, then that would be 60. Okay. This graph matches this table, and just for good measure, let's finish it off with an equation. If that equation looks like this, what would this equation look like?
Y times 12.
Yes, that is seriously is all it is, you guys. Y equals 12x. Let me just make sure you really understand what I mean by why it's not proportional. Because if I added, like, let's say, Oh, plus 2. So, yeah. So then if I put 2 in here and got 24 and added 2 to it, then that would be what? 26. And is 2 feet 26? No. So do you understand why that plus or minus at the end is a no-no? Because then it's not proportional anymore. Because 1 foot is not 14 inches, meaning 12 plus 2. Do you understand proportional relationships? So, I seriously need you to be able to do 3 things. Yes or no, yes or no, yes or no. So, the graph of a proportional relationship is a straight line through the origin. In an equation, it cannot have anything added or subtracted. The table is probably the hardest one, isn't it? You may use calculators to figure the tables out. So, as you work through your maze, you literally just have to know how to do all 3. Do you understand? Okay, Reese. Yes, when you're doing your table, it's always the y divided by the x. So you have to divide and flip it like that. Okay? We good? Yes, Nick. Yes, you may. Absolutely. Yep. Yep. Okay.